Thank you. And hello, everybody. I'm going to go into share screen. So I want to tell you a little bit about myself first so that you understand how I went from architecture into construction management. So you're going to get to see a spectrum of things that I've done. And by way of that explanation, I'll talk to how my training as an architect helped me build a lot of buildings all over the United States. So the first thing you need to know is that I'm a graduate of MacArthur High School. And I went to Carnegie Mellon University and West Virginia University. I got my degree in architecture at Carnegie Mellon. I did these kinds of drawings, and I learned very early on that I like coordinating a lot of work and a lot of complicated work. So these drawings give you a little bit of a flavor of how I was trained. I've worked in New Mexico, West Virginia, Stony Brook, in Las Vegas, at the City University System, at the Diocese of Rockville Center, and now I teach full-time at Farmingdale State College. I'm also the chair of the Architecture and Construction Management program. In New Mexico, I learned how to work to design buildings and work with people that were building the buildings directly. This project right here was a very large vocational technical center that was being built by the residents of an addiction treatment facility. And I had to learn how to communicate well, both in technical terms and also to work with the various aspects of project management. I did some design competitions and designed solar housing. This is 40 years ago now. I moved on to West Virginia University to get a master's degree, and I wound up building the equivalent in today's dollars of $500 million of facilities, almost 400,000 square feet, including a business and economics building, several buildings on the engineering campus. I moved this building, which was not a design project. This was a construction project. It was built in the 1790s, a prefab building. It was carried over the Appalachian Mountains and built in Alderson. We had to move it from Alderson to Jackson's Mill, and I learned a lot about construction assembly and details by working on this building. And then I worked on building both ends of Mountaineer Field. This is the campus where I built a 250,000 square feet of research space and received a $25 million grant to build building 4. So I had to learn a lot about cost estimating, which I learned from building projects 1 and 3 and 5. I then moved to Las Vegas. I built a 300,000 square foot library. And by this time, I was no longer designing projects directly. I was hiring architects and helping them plan the projects. And then I was hiring contractors, and we would schedule and build the projects. This is the library. This is the architecture school. I started teaching there part-time. I moved back to New York several times. I worked at the Stony Brook campus where I helped locate the Student Activity Center. I built an addition to the Life Sciences building. And then when I worked for CUNY, I had to do the planning for the demolition and reconstruction of a building that had been damaged in the 9/11 attacks. This is the original building. We had finished a $60 million renovation, and then 2 weeks later, number 7 World Trade Center fell on it. This is what it looked like. This is the building that replaced this building here. It had 85 classrooms, a digital library, and faculty offices. I then went to work for the Diocese of Rockville Center, and I worked on a variety of church addition and renovation projects. These projects, I again managed the hiring of the architect, the hiring of the contractor. I actually got to do some design work myself. These 2 small chapels I developed here. This church was damaged in Superstorm Sandy. This is what it looked like before. This is what it looked like when I was finished. And then I basically directed the renovation of the exterior and the interior of St. Agnes Cathedral. This is what it looked like before I started. This is what it looked like when I finished a 2 years phased renovation. So in my career, I've gone from being a designer to a designer and a builder to a design builder and then a builder. I started teaching in Farmingdale in the year 2006, part-time, while I was building work for the diocese. I taught design, and I also started to teach construction management courses, which is what I do now. So I've had a pretty good life being both an architect and a contractor. I learned a lot of leadership. A lot of the leadership that I learned was from being a scout. I earned my Eagle Scout Award. I worked at Ontario Scout Reservation. I did a lot of traveling. These are some of my sketches from Iceland, from London, from Washington, from Texas, from the Great Wall of China to the summer palaces in Beijing. I've been a contributing author that built upon my construction management experience. We'll talk a little bit about this. Plan reading, which is an essential activity for construction managers. So I wrote this chapter to explain to construction lawyers what the basic rules for plan reading are and what skills you need it. And so over the last, now it's 40 years, I've supervised over $1 billion of construction work in various locations. And I belong to the American Institute of Architects and the American Institute Society of Engineering. Let me just get out of this and let me go to why you are all here. You are all here because you want to know something about construction management. So our program at Farmingdale State College, the name of the degree is Construction Management Engineering Technology. And that's because we have a blend between the kinds of courses you need to manage projects and the kinds of courses you need to understand how to design a structure, how to drain a site, how to prepare the site to accept a foundation. Construction management is a very, very broad discipline, but it's intertwined with architecture and real estate activities. So I have a diagram here, and let me just go into the slideshow. This explains the overall relationships that take place when somebody has an idea about building a building and when the building actually gets built. You have to have an owner or a client. That's an interchangeable term. You have to have somebody to design the project. For buildings, it's architects. For roads and bridges, it's civil engineers. For industrial plants, it could be a mechanical engineer. And then we need a builder. So a builder could be anything from a general contractor to a construction manager. The difference between the two, and we'll go into it in a little bit greater detail, is that a general contractor actually hires the workers and they have direct responsibility for construction. A construction manager may hire several contractors and coordinate the scheduling, the payments, the ordering of materials, and has less responsibility. So construction management is a very broad term. Each of these three key players in a project are all involved in these 5 basic tasks. We have to design the project. And so we do a lot of planning. We have to look at the codes and permits. We do a schematic design, and I'm sorry, I missed the C instead of the K, where you come up with a concept and then you refine the concept into detailed construction documentation. And then those construction documents are used to prepare estimates and accept bids from contractors who then work with the client or owner and the architect to make sure the project is built in accordance with the drawings and specifications. So, one of the things that a construction management professional needs to be aware of are how these three groups relate to each other on a project and how they allocate the responsibilities for executing their parts of the project and making sure that risk, which is a primary issue in construction projects, is managed appropriately so that we have safe working environments, we wind up with safe buildings, and we protect the health, safety, and welfare of all the people involved with the project development process. So, in construction management, some of the soft skills that we need to learn is how to look at a set of drawings and identify if the project is buildable. We need to understand how long it will take to build the project. We need to know something about the price of materials, how much material we need to bring in to build the building, and then what that will mean in terms of the overall cost, plus the markup for profit and overhead, because contractors and construction managers don't do the work for free. Then we have to bid to owners once we've looked at the schedule, looked at the estimate, made sure the building can be built. We provide those prices. We go and hire subcontractors because a general contractor can't do everything. We get electricians, we get plumbers, we get HVAC tradespeople. They all have their own companies, and those companies take on large portions of providing the work. And then obviously, to make sure that the building conforms to the building code and is built in a safe and risk-free way as possible, construction managers have to be good managers of the regulatory requirements that they will encounter during construction. So, one of the first things you need to know is how to read drawings and specifications. And this is a picture of some of the tools that a construction manager will need to use in order to begin to understand how the building will be built, how it will be priced, and how it will be bid. And drawings are organized so that they just don't kind of draw things in an unorganized way. It's organized by discipline. There are plans, sections, and elevations. There are construction details, construction notes, and material and equipment schedules. So I'm going to pull up a sample drawing so that you can see what a construction manager or a general contractor will look at. The architect draws this in consultation with engineers who deal with the fire protection, plumbing, mechanical, and electrical. So the architects, they'll put together the design criteria, the site plan, some of the drainage details at the site. They'll show this is a basement plan. This is the top of the foundation wall. This is how the floor joist will sit on the wall. This is the floor plan of the first floor. This is the framing elevations for each of these walls. More of that. The second floor joist, the second floor plan. This shows the walls at the second floor and the roof. This shows the ceiling joist, the roof joist. This begins to show you how the solar panels will sit on the house. This shows you the various ceiling plans. And then elevations. These are showing you each side of the house. This shows you interior elevation, so you know how to put in cabinets. But all of these drawings are organized to help the contractor and his material suppliers understand all the parts of the building that need to be accounted for in putting together an estimate and a safety plan and an overall bid. This is a section through the building. So it's like we cut the building in half, and now we can look at how the structure works. More sections. And then these are construction details, so we can understand how all the materials come together. And this is a very interesting drawing in that it shows you the sequence of all the key parts of the building and how it will be built. So for a construction manager, this is an excellent drawing because the architect is providing some clear direction as to how each part of the building should be assembled. And he does this and is quite detailed. You normally don't get that in drawings. And then there are window details, door details, duct details. It's a very, very detailed approach to providing information. These are window schedules. This is the window elevations. This is telling you the size of the window and how many. These are the door schedules. This tells you how many doors we need and what size. We'll just kind of go in real quick. And you can see here, it talks about if it's an interior door, an exterior door, if it's a swing door, a double swing, or a pocket door, which means it's a sliding door. So one of the first skills you need to learn when you're entering the construction management profession is how to read drawings. And if you were to read my chapter on plan reading, you would find out what this corner label means, how the title block is laid out. We could speak just about that for another 2 hours, but we're not going to. We're going to move on. And talk about specifications. So specifications provide the qualitative statements. Drawings explain measurements, the quantitative statements. Specifications explain the nature of the materials, the quality of the materials, and how to store the materials. And it does it by different kinds of building systems. But the primary purpose of specifications for a construction manager is to help organize the construction cost data, organize trade and technical literature that you might get in order to select windows and doors and countertops, and oftentimes to coordinate notes on construction drawings so that there's a link between the specifications and the drawings. So there are over 50, there are 50 divisions for specifications. Generally for building projects, we work with the first 33. So we talk about how we're going to buy the project, then we talk about general requirements that are associated with all the other 30 sections, and then existing conditions deals with when we deal renovations or demolitions, concrete for pouring steps and foundations, masonry for building brick walls, metals for metal beams and metal fences, wood, plastic, and composites for building wood frames, thermal and moisture protection for siding, sheathing, and roofing, openings for windows and doors, finishes for all the interior walls and paint and flooring. Then specialties, equipment, and furnishings are specific to building types. Special construction when we're building pre-engineered buildings, or we're building very specialized kinds of building types like explosive test cells, we might have requirements in Division 13. Conveying equipment is elevators and escalators. And then Divisions 21 through 28 all deal with building systems. Fire protection, plumbing, HVAC, heating, ventilation, air conditioning, integrated automation, electrical systems, communication, electronic safety and security. And finally, the outside work, the site work and earthwork when we have to do excavation for basements, exterior improvements when we build roads and walkways and plant trees, and then how we bring water and gas and electricity to the site. Then with each of those divisions, like in metals, it will have sections that talk about very, very specific technical things. Structural steel, steel joist, steel decking. And so one of the things our students learn at the beginning of their journey at Farmingdale is that we have 2 materials and methods courses where you begin to learn the difference between light construction, which is residential and small commercial, and then heavy construction, where we're dealing with structural steel framing and steel decking. So specifications help to frame the knowledge that students, and then ultimately when they become project managers, how they will go about identifying the quality of the materials that they need from the drawings. So then once we've read the drawings and we've read the specifications and we begin to understand what it is we're going to build, now we need to understand how much material are we going to need and how much will it cost, because people are always, they're not going to give you unlimited funds. You need to set a budget. So we estimate to identify what the probable construction costs are. We look at the plans in the project manual, that includes the specification, so that we can establish the project budget, ultimately order materials if we get the job, and then identify what kind of profit we're going to make once we've met all of our direct costs for materials, equipment, and labor. So there are 3 types of estimates. There's conceptual, and that's based on historic data. So architects and contractors will collect the costs of projects and make files and be able to determine how much a project might cost on a square foot basis based on, let's say I built a 3,000 square foot bank and it cost me $300,000. I would divide the 300,000 by 3,000 and I would get my cost per square foot. But you need a lot more information if you're going to compete in a bidding situation. So in a bidding situation, you're up against other contractors who are reading the same set of drawings and reading the same set of specifications and trying to figure out how they're going to price it so that they get the job. You can do that sometimes with assembly elements, and it kind of blends some of the historic data of the conceptual, but it also begins to assemble groups of elements. So like in a wood stud wall, I might say I got to have the top plate, the stud, and the bottom plate, and I build a price based on having those 3 elements together. Most of the time, construction managers and contractors have to establish a unit price where they look at a detailed quantity with estimates of labor and equipment use, and they look at how they're going to build the building. So we'll talk about scheduling in a little bit. Conceptual estimates generally don't understand or don't acknowledge the means and methods that contractors use. Assembly elements, they don't do it either. It's the unit price that lets a construction manager or a contractor really begin to identify what their risk is for either not making money or making a good profit. So now we're going to do a quick conceptual estimate. I developed this workbook to help me begin to budget based on a lot of historic cost data, but I figured out a way that I could begin to work with means and methods. So one of the first things you need to do is become familiar with spreadsheets. If you have an opportunity in high school to learn how to use a spreadsheet, do so, because it's a very important tool. Estimates are done on spreadsheets. Scheduling is done on spreadsheets. Structural calculations are done on spreadsheets. Presenting a lot of data is done on spreadsheets. So in this approach, this is a workbook with 5 sheets, and we're going to start in the back. So this is a guide that shows how costs are affected by location. So if we assume that the national average for a cost is 1, this chart is telling us how much over or under the costs are. So in New Mexico, I can build things for 14% less than the national average. On Long Island in Nassau County, I'm going to spend 44% more than the national average. And we know that a lot of things are expensive on Long Island. So we need to remember this 1.44. Then we have a table, and it's organized by the International Code Council. It comes out every 6 months. And it is based upon a survey of building code officials on how much projects cost based on the type of building. That's what this list is right here: A, B, E, F, H, I, M, R, and U. And then the construction type. So there are 5 construction types. Construction type 1A and B is steel frame or concrete reinforced. It's non-combustible. Type 2A and B is fire resistant. Type 3A and B is masonry with protected joist. Type 4 is heavy timber. And type 5 is probably what you see every day. It's wood frame construction or metal construction built out of wood studs and rafters. So your house, unless you live in an apartment building, is basically a type 5 A or B house. And the difference is there's a little bit more care taken to provide fire resistive surfaces and protection of the structure. So we're going to do an estimate for a 1 or 2 family house, and we're going to make it 5A. So we're going to go, and we have to go here, and we have to look at 5A. So we're going to look at a price of let's just get rid of this. We're going to look at this number right here. So we need to put this number in. Now, remember, we're on Long Island, so we got to pay a lot more. So we got to put in the 1.44 from the table, and it adjusts the cost. So where in the national average, you'd be paying $138 a square foot for a house. On Long Island, you're going to pay $199. So now let's go. I've set up this spreadsheet so that it will take that price and add fees that I need to calculate for the architectural services and then the project management services of the construction manager or general contractor. So now that increases the price from $199 to $218 a square foot. So then I go to my project worksheet, and that number is already there. I'm going to build we'll build a 2,200 square foot house because that's the standard size of the house on Long Island. And all of a sudden now, my numbers are generated by taking this space by this number, and it comes up with a total number of $479,258. Now, here's where my means and methods come into play that it normally doesn't on square foot cost. So I did a study with 100 projects, and I came up with some factors that would adjust this cost up or down. So the project is less than $1 million. So generally we pay a little bit more because in a construction company, we're going to have to carry some of the overhead on a smaller project in a way where it's more than if the project were more than $1 million. So we hear that we don't have enough skilled trades on Long Island. That could increase the price of the project by 7%. Then if we're in a small village, we're going to pay a little more because they're more focused on regulating construction. So we're going to pretend that we're building in Levittown, which is an unincorporated area, and we're going to put in equals F8. And that reduces the cost in terms of what the contractor might find is an acceptable risk. And then, as we know, we don't have a lot of space in Levittown to build on open lots. So we have to pay a little bit of a premium. We want to make sure that we do tests. So we may drill down. So we'll go ahead and put that in. And that reduces our cost. And then we have a simple project. So you'll see numbers in parentheses and numbers that are non-parentheses. The parenthetic numbers reduce the cost. These numbers increase the cost. So all my factors, I wind up with $110,000 in cost beyond my $479,000. And then I have to add overhead and profit. We use a standard allowance, which is about 20%. So we add on another, based on this number plus the other number, about another 117,000. And now the number is 707,000. And then if I have any delays, so if I am waiting for permits or so forth, and it takes 2 years and I got to go to a year, I got to add on more money. So all of a sudden now, what started at $479,000 is $848,000. What I've done is that I can put this number in here, which is the size of the house. And again, based on my study, I figured that out of this total number, 75% is construction. I have money set aside for the architect's fees. I have pre-designed services for doing tests, building permits, reimbursable expenses. And so this number and this number balance out. And I'm basically, for construction, spending about $300 a square foot. And for project cost, I'm spending about $386. So construction managers have to understand how to take a lot of complex data in terms of the cost of materials, the size of spaces, and then using some standard allowances to calculate permits, profit, contingency. A contingency is money you set aside for unforeseen conditions. So like on a project that I had several years ago, I was digging into the ground and I found a 1930 A model Ford. You need to be able to anticipate spending more money to take out the truck, and then because there might be oil there, you have to take out the soil and make sure that it's decontaminated. So we just did a very simple cost estimate to give you a flavor for why you need to know spreadsheets and why your math skills and being able to link complex formulas will come in handy. So let's go This is the estimating process. So let's zoom in. This is where we talked about the drawings and the project manual. So you need to review the construction documents. Then you have to break it up into work packages. You have to schedule the estimate, and then you're going to do a quantity takeoff where you're going to look at your required equipment and materials. You're going to look at subcontractors. Remember, I talked about hiring electricians, plumbers, and HVAC. And then you're going to need to look at how you're going to schedule your labor. So you have to do your labor, you do your project scheduling and duration so that you can identify the amount of labor and then come up with all the other costs in support of these direct activities. So we have indirect costs for insurance, for sales tax, for renting portable toilets, for getting the permits, and then we need to identify what kind of profit we expect to achieve from this project. So this generally it is a lot of work, and it's generally done in 3 to 4 weeks by teams of people with a chief estimator in place. So one of the specialties that you can pursue in construction management is becoming an estimator. An estimator will always make an excellent living if his estimates are consistent. And so all that work kind of gets put together as a document to identify the labor requirements, make sure that we understand all of the costs, and then we have a summary of the estimate that we can either use to give to the owner to see if he still has enough money to pursue the project or to submit a bid. So once we have that done, the bidding process is governed by different kinds of project delivery methods. So we have design bid build, where the owner will hire an architect separately and then go out and hire a general contractor separately. The architect works on behalf of the owner to monitor the contractor. So the purpose in design bid build is to have checks and balances between the owner, the architect, and the general contractor. In design build, the owner hires one team where the architects and the contractors, construction managers are all together. And what it does is that a lot of constructability issues can be resolved before projects are bid out to subcontractors. So there are fewer checks and balances. An owner needs to be a much more vigilant observer of this process, but you can achieve real cost savings. I did a design build project out in Sayville about 10 years ago. When I estimated it as a design bid build project, it came in at 1.8. Because I used design build, it came in at 1.3 million. So there are special contracts, there are special mileposts that you need to set up in your overall project. Construction management, the owner hires an independent group to oversee the design and the construction of the project. So the CM helps the owner manage the architect and manage the construction contractors. That's what I did for 35 years. I basically wound up being the construction manager for many projects on behalf of the owner. There are times I would hire a construction manager where the projects became too complex. So I, in this role, would act as an advisor. The construction manager doesn't do the actual construction work. That's why they hire these contractors. So there are some CMs that say, you know what, we'll go ahead and build it. We'll combine both roles. They take risk because they have to put an overall price together for the project. Then turnkey, we would also have financing that would go along with the CM approach. And then Program management, which is a single purpose entity, that's where we have one legal group that may be managing multiple projects. How do we pay for all of this? So there's fixed fee. The risk, this is something that's risky for the contractor or the construction manager, because if there are unplanned construction costs, he just can't ask for more money. That's the way that has to be done, is through the contract by a change order. And the owner may not agree to the change order. So where there's a well-defined project, well-defined drawings, well-defined specifications, lump sum is the best. Cost plus a fee, the owner pays all the direct cost plus a fee. The owner assumes more risk because they have to monitor all of the cost and make sure that the general contractor or the construction manager are not spending outside of the bounds of the contract. And so you might want to use that project where you've started designing parts of the project and you want to build them while you're designing other parts. And so adding a guaranteed maximum price wants to make sure that we shift some of the risk back from the owner to the construction manager. And then there are different special provisions where we might reward the contractor for finishing early and share some of the savings. There are insurance bonds specific for construction where we might ask the contractor to buy a bond so that if he doesn't finish the project on time, or if he's incapable of completing it, that the owner can go make a claim against the bond and finish the project themselves. To make all of that work, we need to understand construction scheduling, and we look at the building through drawings and specifications, and we begin to understand how we're going to build it. Where are we going to start? Generally, we start in the ground, and we start with the foundations, we build the structure, then we build the interiors, and then we add more systems as we go along. We can phase construction, and there's some risk with phased construction. You have to very carefully align your schedule with what they call a schedule of values that your construction manager or your general contractor will maintain to align how they get paid to the progress they make on the job. So this is a simple schedule. It's called a Gantt chart. You can actually do this on a spreadsheet where you list all the tasks, and then you make a series of milestones per month and by week, and then you can show how long it takes to do that particular part of the project once you've calculated your labor and equipment needs. There are some schedules where we need to know what the most direct path to the finish is. So when we start at 1, we can see that the critical path is task 1, 4, 5, 6, 7. It's the most direct to the end. Some of these other tasks are not in this path that's most important to be on time. You have to finish all these tasks in their sequence, and when they specify their completion, it's sequential, and you have to track it every day, not just every month. This is an everyday monitoring. So the general contractor has to make sure he oversees the construction, controls the project site, manages all the trades under his direction, and the subcontractors and material suppliers bring materials in to be used by the trades and the subcontractors, and then coordinates all the communication between the construction team, the owner, and the designer, whether it's an architect or an engineer. So a lot of times that will include filing construction permits, putting up a fence to secure the site, temporary water and power, setting up office trailers and support facilities, again, like portable toilets, getting insurance coverage, managing the personnel, managing a safe work environment, stockpiling materials, testing and quality control, like making sure the concrete is strong enough to hold the structure, providing for site surveying and engineering to do a proper layout and to arrange for cranes and other construction machinery to be there in support, making sure that the materials and the structure are protected from inclement weather, getting accurate records, cost and schedules, managing changes, and much more. Now, with the emphasis on how do we respond to climate change and trying to be more environmentally conscious, we need to make sure that in construction management activities that we begin to reduce the carbon footprint and energy expenditures of the building and construction sector of the economy, which accounts for almost a third of all the worldwide energy consumption. So this will tell you that in the United States, construction and operations of buildings, 1/3 of the energy, 70% of the electricity, 12% of drinking water, and 30% of raw materials. And in addition, it generates a lot of solid waste, which of course on Long Island, we no longer have room for. So one of the costs that construction projects have to account for is bringing a lot of solid waste to rural states where they have landfills, where this material is placed so that it will degrade and hopefully go back into the environment. So a lot of the CO2 emissions, greenhouse gases, construction generates as much as 45%. So you'll see in construction now, there's a much greater sense of having to know the properties of materials and their ability to reduce the overall carbon footprint. So we want to make sure that as we become good stewards of the construction process, we make sure we reduce our use of natural fossil fuels, that we preserve land that can be used for agriculture, we protect ecosystems and water resources, we minimize air pollution, generating a lot of waste, and we want to make the buildings as healthy as possible. So we rely on architects to use green building approaches, and then construction managers need to understand the technical principles to minimize the environmental harms and make sure that we don't build buildings that negatively impact the environment. So we need to know something about the sustainability of materials through product data sheets, environmental labels, product disclosures that explain how the materials were extracted or how they were manufactured and what their carbon footprint is, so that we can try to reduce the overall carbon consumption of the construction process. There are environmental product declarations that as a construction manager or construction contractor, you need to understand so that you can contribute to the goal of making construction more sustainable. So recycled materials, bio-based materials like wood, mass timber, making sure that we can renew materials, like we can take down steel frames after a building's been demolished and recycle the steel. And then we try to reduce the amount of transportation that we need to bring materials to our construction site. So when we are sustainable in our construction practices, we can save almost 35%, but it'll vary from building to building based on the building type and the complexity of the building. So what are some of the trends that construction managers and other construction professionals need to be aware of. We need to make sure that owners, contractors, and designers work more closely together. And there's a lot of movement towards integrated project delivery. We are doing that because of something that we'll talk about it in depth in a little bit, called BIM, Building Information Modeling, which allows us to visualize the entire building construction down to a bolt in a steel frame building. And then we want to make sure that we use scheduling and labor, equipment, and materials analysis to reduce the amount of waste. So when we're looking at building information modeling, we can actually build 3D models that use the data from the estimate, from the specifications, and the schedule to actually begin to provide a very rich data stream to owners, architects, engineers, and contractors working on the same project. For general construction, it helps to link all the planning that the architects do with the planning that the contractors and construction managers have to do for actually building the project. And there are just some things that I want to bring to your attention to think about now while you're in high school. So first of all, you should not blow off math and science classes nor business and economics classes, because everything that I just described requires you to use math and technology in support of planning and executing a construction project. So it's good to work on those particular skills while you're in high school. Know and learn spreadsheets. I can't stress that enough. Begin to look at drawings. If you have an architectural drawing class, just go and see what they're doing so that you learn some of the conventions. Some of the Regents exams that you need to pay attention to in order to build a strong basis to go into construction management in college. Your Algebra 1, Geometry, and Advanced Algebra and Trigonometry. And trigonometry is actually pretty important. English 1, 2, and 3, because specification writing is not easy. And you're going to be writing with a lot of technical terms. So being able to write well is an important skill for a construction manager. And then technical drawing. You should learn some of the basics, learn how drawings are organized, learn how to read drawings so that you have good skills as you enter college to begin to learn about materials and methods, to learn about estimating, to learn about construction safety. If there are opportunities in your school to volunteer for a Habitat for Humanity project or do a small construction project under the supervision of a teacher or a group of professionals, do it and learn something about construction before you come to college. You might want to get a part-time job if you're old enough, being a helper on a construction site, helping to bring materials to where they need to be on a construction site, even getting the coffee. You'll learn a little bit about when people have to take breaks in order to conserve their energy to be productive. And then if there are opportunities like this at libraries and at museums to learn more about construction, you should go in and do it if you're interested in learning construction. It's a very broad and complex field, but I have enjoyed the 40 years that I've spent in construction management. I've built a lot of things. When I go around Long Island, and I've built projects at almost 60 parishes. So no matter where I go in Long Island, I see something that I've done, and it's a great feeling.